Hi friends, welcome back on our YouTube channel. Today in statistical mechanics we are going to discuss about classical ideal gas. We have already discussed about ensemble and especially microcanonical ensemble. Now classical ideal gas. So let's start classical ideal gas. So here we will discuss about classical ideal gas. The Hamiltonian of a system H is equal to 1 upon 2m sigma I equal to 1 to n pi square. Here m is mass and pi is momentum. Since sigma E is equal to 1 upon h raised to 3n, integration h is less than E, d3p1, d3p2, d3pn, d3q1, d3q2 up to d3qn. And since integration dp dq is equal to h, so here h is constant of the dimension of momentum into distance, and we used it here to make sigma E dimensionless because here we get h raised to 3n. Since integration dp dq equal to h, so to make sigma E dimensionless, we divide this by h raised to 3n. Integration dq1 dq2 up to dq3n is equal to integration dx1 dy1 dz1, integration dx2 dy2 dz2 up to integration dxn dyn dzn. And since this is v, this is also v, and this is also v, so v into v into v, so this will be v raised to n. So integration dq1 dq2 up to dq3n is equal to v raised to n. Therefore integration h is less than E, d3p1, d3p2 up to d3pn, d3q1, d3q2 up to d3qn is equal to v raised to n. Integration h is less than E, d3p1, d3p2, d3pn, because this is our v raised to n, and therefore this will be this one, or this will be equal to v raised to n omega 3n r. Now integration h is less than E, d3p1 d3p2 up to d3pn, d3q1 d3q2 up to d3qn is equal to v raised to n omega 3n r. Here p is equal to root of twice mh. Now p is removed with r and h is removed with e, so r is equal to square root of twice me. Also p equal to x is less than r since h is less than e, so h is less than e, so p is equal to x and x is less than r, where omega nr is the volume of n sphere of radius r, and it is given by omega nr is equal to integration x1 square plus x2 square plus xn square is less than r square dx1 dx2 dxn. So here omega 3nr, and here omega nr is actually volume of an n sphere of radius r, and this volume is given by this equation, and this is equal to Cn r raised to n. This Cn is actually constant. Now evaluation of Cn. For it we use identity. Integration minus infinity to plus infinity e raised to minus x1 square dx1 into integration minus infinity to plus infinity e raised to minus x2 square dx2 up to integration minus infinitive to plus infinitive e raised to minus xn square dxn, and this is equal to integration minus infinitive to plus infinitive e raised to minus x square dx whole power n. So we use this identity here. Now integration minus infinitive to plus infinitive e raised to minus x square dx is equal to root pi. So this is root pi, and here we have power n. It means this will be pi raised to n by 2. So this is equal to pi raised to n by 2. Let the surface area of a sphere of radius r be S n r is equal to d by dr of omega n r, because omega n r is actually volume, and if we differentiate volume then we get area. So let the surface area of a sphere of radius r be S n r, and S n r equal to d by dr of omega n r. Now from here d omega n r equal to S n r dr. So we cross multiply this equation and we get d omega n r equal to S n r dr, or omega n r equal to integration S n r dr, because this is actually d omega n r. So to get omega n r we integrate this equation. So omega n r is equal to integration S n r dr. Now omega n r is equal to integration x1 square plus x2 square up to plus xn square is less than r square dx1 dx2 dxn. So we replace this with this one and we get integration x1 square plus x2 square plus xn square is less than r square dx1 dx2 up to dxn is equal to integration snr dr. Now we get this equation. So integration minus infinitive to plus infinitive dx1, integration minus infinitive to plus infinitive dx2 up to integration minus infinitive to plus infinitive dxn e raised to minus x1 square plus x2 square plus xn square is equal to integration snr dr e raised to minus r square. So this is our this one, and x1 square plus x2 square plus xn square is actually r square. So this will be e raised to minus r square, and this will be equal to ncn integration 0 to infinity dr r raised to n minus 1 e raised to minus r square. Now let r square equal to t. So on differentiating this one we get 2r dr equal to dt. Now dr equal to dt upon 2r, so we transfer this 2r from here to here, so dr equal to 1 upon 2r dt. And since r square equal to t, so r is equal to root of t, so this r is replaced with root t, so dr equal to 1 upon twice root t dt. So integration 0 to infinity dr r raised to n minus 1 e raised to minus r square, which we require here, and this will be equal to 1 upon integration 0 to infinity t raised to minus half dt t raised to half whole power n minus 1 e raised to minus t. Since r square equal to t, so we replace this r square with t, so this will be e raised to minus t, and here we require r, and r equal to root of t, that is t raised to power half. So we replace this r with t raised to half, so t raised to half whole power n minus 1. Now and this dr is actually 1 upon twice root t dt, so 1 upon 2 t raised to minus half dt, and this will be equal to 1 upon 2 integration 0 to infinity, and this is t raised to minus half, and this is t raised to half power n minus 1. So this will be t raised to n by 2 minus half, and this is t raised to minus half. So this minus half and this minus half is actually minus 1. So if we multiply this and this one, then we get t raised to n by 2 minus 1. So integration 0 to infinity dr r raised to n minus 1 e raised to minus r square will be this one. Now integration 0 to infinity x raised to n minus 1 e raised to minus x dx is equal to gamma n. So this will be equal to 1 upon 2 gamma n by 2. Now this one is equal to this one, and this is equal to half gamma n by 2. Also this is equal to pi raised to n by 2. Now we replace this with pi raised to n by 2, and this is with 1 by 2 gamma n by 2. So this equation will be pi raised to n by 2 is equal to ncn 1 upon 2 gamma n by 2. Now from here ncn is equal to pi raised to n by 2 divided by half gamma n by 2. So to get ncn from here, we transfer this term from here to here. So ncn is equal to pi raised to n by 2 divided by half gamma n by 2. And therefore Cn is equal to pi raised to n by 2 divided by n by 2 gamma n by 2. So we transfer this n from here to here, and we get Cn, which is this one. Since x gamma x is equal to gamma x plus 1, so this will be equal to gamma n by 2 plus 1. Therefore Cn is equal to pi raised to n by 2 divided by gamma n by 2 plus 1. Now gamma x plus 1 is equal to factorial x, so this will be factorial n by 2, and therefore Cn is equal to pi raised to n by 2 divided by factorial n by 2. Now Cn is equal to pi raised to n by 2 divided by factorial n by 2. Now if we take log of this equation, then log Cn is equal to log pi raised to n by 2 minus log factorial n by 2. So log pi raised to n by 2 minus log of factorial n by 2. From log m raised to n, this will be equal to n by 2 log pi, and this is as it is. So n by 2 log pi minus log factorial n by 2. From Stirling approximation, log of factorial n equal to n log n minus n. So this will be n by 2 log n by 2 minus n by 2. So log Cn is equal to n by 2 log pi minus n by 2 log n by 2 minus n by 2. So we use Stirling approximation here, and Stirling approximation is given here. Now if we open this bracket, then this negative and this negative will be positive. So log Cn is equal to n by 2 log pi minus n by 2 log n by 2 plus n by 2. In the same way, if n is replaced by 3n, so log C3n is equal to 3n by 2 log pi minus 3n by 2 log 3n by 2 plus 3n by 2. So we replace this n with 3n. So this will be 3n, this is 3n, this is 3n, and this will also be 3n. So log C3n will be this one. Now this will be equal to log pi raised to 3n by 2. So we apply n log m equal to log m raised to n here. So this will be log pi raised to 3n by 2, and this will be log 3n by 2 whole power 3n by 2, and this 3n by 2 written here. We use log m minus log n equal to log m by n here. So this will be equal to log pi upon 3n by 2 whole power 3n by 2, and this 3n by 2 is written here. So log C3n equal to log pi upon 3n by 2 whole power 3n by 2 plus 3 by 2 n, and this will be equal to log 2 pi by 3n whole power 3n by 2 plus 3 by 2 n. So we transfer this 2 from here to here, and this will be equal to log 2 pi upon 3n whole power 3n by 2. Since integration h is less than e, d3p1, d3p2, d3pn, d3q1, d3q2, d3qn is equal to v raised to n omega 3nr, and omega nr equal to cnr raised to n. So we replace this omega 3nr by C3n r raised to 3n. So if we put 3n here, then 3n will be here and also 3n here. So omega 3n r is equal to C3n r raised to 3n, which is written here. So this value will be v raised to n C3n r raised to 3n. Now r is equal to root of twice me. So this will be equal to Vn C3n twice me power 3n by 2. So we replace this r with root 2me or 2me power half. So this will be equal to v raised to n C3n twice me whole power 3n by 2. Since sigma e is this one, and this is equal to v raised to n C3n twice me power 3n by 2. So we replace this term with this one, and therefore sigma e is equal to 1 upon h raised to 3n v raised to n C3n twice me power 3n by 2. And this will be equal to C3n v upon h cube twice me power 3 by 2 whole power n. So n from here, also from here, and also from here, we take whole power n. So sigma e equal to C3n v by h cube twice me power 3 by 2 whole power n. Now, entropy of an ideal gas is given by S is equal to K log sigma E. Here K is Boltzmann's constant and sigma E is this one. So, we replace this sigma E with this quantity. Therefore, S, that is entropy, is equal to K log C3n V by h cube twice me power 3 by 2 whole power n. Now we apply log m into n equal to log m plus log n here. So S equal to K, and this will be log C3n plus log V by h cube whole power n plus log twice me whole power 3 by 2 n. So on applying log m into n equal to log m plus log n here, we get this value. Since log C3n equal to this one, so we replace this log C3n with this term, and therefore S equal to K log 2 pi upon 3n whole power 3n by 2 plus 3 by 2n plus log V by h cube whole power n plus log twice me whole power 3n by 2. Now we combine this and this term. We get s equal to k log of v raised to n 2 pi by 3n twice me into 1 upon h square whole power 3n by 2, and this 3 by 2n is written here. Now this will be equal to s equal to k log v 2 pi by 3n into twice me into 1 upon h square power 3 by 2 whole power n, and this n will be in multiplication because log m raised to n equal to n log m. So s equal to nk log v 4m pi upon 3h square into e by n power 3 by 2 plus 3 by 2 nk, because this k will also multiplied with this one. Now on solving above equation for E, so if we solve this equation for E, so first of all this 3 by 2 nk will transfer from here to here. So s minus 3 by 2 nk is equal to this term. Now we divide with nk. So s minus 3 by 2 nk upon nk will be this one. So s minus 3 by 2 nk upon nk is equal to log v 4 pi m upon 3h square into e by n power 3 by 2. Now 3 by 2 is only with this power. V can also be written as v raised to 2 by 3 whole power 3 by 2. Now this will be nk log of v raised to 2 by 3 4 pi m upon 3h square into e by n whole power 3 by 2. Now this 3 by 2 can be transferred into the multiplication. So s minus 3 by 2 nk upon nk equal to 3 by 2 log v raised to 2 by 3 4 m pi upon 3h square into e by n. So we apply here log m raised to n equal to n log m. Now we transfer this 3 by 2 from here to here. So s minus 3 by 2 nk upon 3 by 2 nk is equal to log v raised to 2 by 3 into 4 m pi upon 3h square into e by n. Now this will be equal to s upon 3 by 2 nk minus 1. So s upon 3 by 2 nk is equal to 2 by 3 s upon nk. So 2 by 3 s upon nk minus 1 will be equal to log v raised to 2 by 3 into 4 m pi upon 3h square into e by n. Now 2 by 3 s by nk minus 1 is this one. Now we take exponential on either side. So exponential here and also exponential here. So exponential log equal to 1. So v raised to 2 by 3 into 4 m pi upon 3h square into e by n is equal to exponential 2 by 3 s upon nk minus 1. And from here e equal to 3h square upon 4 m pi n upon v raised to 2 by 3 exponential 2 by 3 s upon nk minus 1. Because to get e from here we transfer this term from here to here and we get this term. And this E is actually our internal energy. So U, which is the function of S and V, is equal to 3h square upon 4 m pi n upon v raised to 2 by 3 exponential 2 by 3 s upon nk minus 1. Now temperature. To get temperature from internal energy, we differentiate U at constant volume with respect to entropy. So T equal to del U by del S at V. So to differentiate this term with respect to entropy, so this term will be constant and e raised to x is e raised to x, so we get this whole term. Now we differentiate this term with respect to s, so into 2 by 3 1 upon n k. So T equal to u into 2 by 3 into 1 upon n k, and therefore T equal to 2 by 3 u upon nk. So if we differentiate this with respect to entropy, then we get this one, and from here T equal to 2 by 3 u upon nk, and therefore internal energy U equal to 3 by 2 nkt. So to get U from here, we transfer this term from here to here. So U equal to 3 by 2 nkt, and here k is Boltzmann's constant. Now U equal to 3 by 2 nkt, and heat capacity or specific heat at constant volume Cv equal to del U by del T at constant volume. So we differentiate this U with respect to temperature partially, and we get 3 by 2 nk. So Cv equal to 3 by 2 nk. So Cv equal to 3 by 2 nk. Now pressure P equal to minus del U by del V at constant entropy, and U is this one. So we differentiate this U with respect to volume at constant entropy. So 3h square upon 4 m pi as it is, n as it is, this whole term as it is, and differential of 1 upon v raised to 2 by 3 will be differential of v raised to minus 2 by 3, and this will be equal to minus 2 by 3 v raised to minus 2 by 3 minus 1. So on differentiating this with respect to volume, this term is constant, which is written here, and differential of 1 upon v raised to 2 by 3 is this one. This negative and this negative will be cancelled out. This 2 by 3 is written here, and this is 1 upon v into 1 upon v raised to 2 by 3. So 1 upon v into 1 upon v raised to 2 by 3. Now this whole term is actually our u. So this is replaced with u. So P equal to 2 by 3 u upon v. So this is our pressure, or P equal to 2 by 3, and u is 3 by 2 nkt. So this u is replaced with 3 by 2 nkt. So P equal to 2 by 3 into 3 by 2 nkt upon v. Now this 3 by 2 and this 3 by 2 will be cancelled out. So P equal to nkt upon v. So P equal to nkt upon v. Here we end our session. In today's session of statistical mechanics, we have discussed about classical ideal gas. So goodbye.